Yeah, good morning, Sebastian, and good afternoon for the rest of the participants today. So this is day 3 of the experimental psychology workshop using OpenSesame. It's facilitated by Sebastian Mathot from the University of Groningen. And today we'll continue our discussion with implementing experimental design using Eye Tracker. So I'll give the screen to Sebastian.
Yeah. All right. Thanks, Vishnu. So yeah, welcome back on this afternoon for you, early day for me. And today in day 3, as we already promised, we're going to take a look at eye tracking and how to include eye tracking in an experiment. And as always, we're also going to spend some time on you working on your own experiment. And it is going to be a little bit more challenging, a little bit freer than the previous days. So we're building up the skill set slightly. So what are we going to do before the break? I will give you a general introduction to eye tracking, so that you have some idea of the concepts, etc. Maybe I will also send you a link to a paper that you can read that is about eye tracking and specifically about pupillometry. So my own research is very much about this, measuring the size of the pupil, but in many ways the techniques are the same as measuring the direction of the eye, of course. And we recently wrote a review article with a lot of very sort of easy, low-hanging fruit tips for doing that. Then we're going to work on a self-paced reading task. That is a very classic task that is used in eye tracking research by psycholinguists. I will explain a little bit about that later, but basically a self-paced reading task means nothing else except you read a sentence and you press a button when you're done, all the while recording eye movements. Then after the break, we're going to pick up and we're going to take this self-paced reading task, which I hope that is not the review article I meant actually.
No?
But thanks
okay.
for
So you have a new
posting.
one. That's great.
Yeah, I will post a link in a bit. It's the one called Mathot and Vilotijevic, Cognitive Pupillometry, Colon Methods, Design and Statistical Analysis, I think. Design, Pre-processing and Statistical Analysis. Anyway, post that in a bit. So after the break, what we're going to do is adjust this self-paced reading task to be a more proper eye tracking experiment, and by making it gaze contingent. Gaze contingent means nothing else than that it responds to your eye movements, so that your eye movements are basically a response modality, just like pressing a button on the keyboard or clicking with the mouse. Clearly, we don't all have eye trackers now in front of us, although we have a webcam, which is already something. We can do this in dummy mode in OpenSesame, where we pretend like the mouse is an eye tracker. So essentially, that's what we're going to do. And then, as before, you're going to continue working on your own experiment. And I suggest then we will do the same as we did before, that we create these breakout room for the people who want to continue on the eye tracking stuff. And I will sort of supervise the main room where everyone works on their own experiment. Okay. So, but let's start actually with a little bit of eye tracking 101. So what do eye trackers record? I should say at the outset, by the way, that a lot of the difficulty in eye tracking is in the data analysis and not so much in setting up the experiment. Here we are going to focus on the easy part, namely setting up the experiment. And we are going to touch a little bit upon data analysis, of course, in next week, but not specifically analyzing eye movement data, for the simple reason that that would not be feasible to do in the scope of this relatively short workshop series. So, but I will at least hope to provide you with the tools and sort of the conceptual knowledge of how that goes approximately. All right, so what do eye trackers record? They always record gaze position. And so that means that you have an X and a Y coordinate, and though both of those are time series, and that just means that you do not have a single value for the X and the Y coordinates, well, or two values, one for the X, one for the Y, but they are values that change as a function of time. This is fairly obvious, right? But I'm just pointing it out. And here on the right side, you see what that might look like. So here we have a figure for the X coordinate, and here we have for the Y coordinate, B and C. And you see, this is from a task where I'm fixating. So you see they're mostly in the center. And time is on the or sample number or time is on the x-axis. So here, this is data recorded at 10 hertz, 100 hertz. So that means that, am I saying this correctly? Yeah. So that means that this is actually 3 seconds worth of data. And what you're seeing here is that basically I'm looking in the center of the screen, and you're seeing here at around sample 100 and 220, these sort of weird jumps. Can anyone guess what that is? It's very characteristic of eye movement data if you analyze it. What would those kind of disruptions reflect?
I think is it a wink?
A blink, yeah, exactly. I'm blinking there. And you see that blinks have a very strong disruption of the signal. They kind of look like you're making this sort of downwards eye movement. You're not really doing that. That is just an artifact of the pupil being slightly covered by the eyelid while your eyes are closing. And then the signal completely disappears for a while, and then it comes back. And one of the challenges during data analysis is actually to deal with those kinds of artifacts. But for our purpose, actually, we're not doing that. We're not really focusing on that. So X and there are many ways. So we're recording X and Y coordinates. There are many ways in which you can express X and Y coordinates. So usually for the kinds of eye trackers that we tend to use, they are relative to a display. So the assumption is that the participant sits in front of a computer display performing a task, and the X and the Y coordinates are calibrated such that, generally speaking, 0, 0 is the top left of the screen, and say 1900 by 8080 the bottom right of the screen, and that is the reference frame. But this doesn't always need to be the case. Actually, Vishnu, you were going to acquire a Adobe Eye Tracker, am I right?
Yeah, so we have one already.
You have one.
Well, it's not working with OpenSesame yet. It's something that I'm working on, but it works with this WyLab program that comes from it.
Okay.
But it's, it's one with the that's mounted on the computer with a sampling rate of 250 hertz.
Okay, yeah, and that is kind of the traditional setup, just like we have here, that you have X and Y coordinates that are relative to a display. You also have eye trackers that are relative to a world camera. I don't actually have it here, but we have an eye tracker called the Pupil Labs, and it actually consists of 2 cameras. One that points at the eye, so it's kind of like it's a pair of glasses, very lightweight, with one camera that points at the eye. And that camera is that records your eye position, of course. And when there's another camera that actually points forward at the world. And then what the coordinates mean is basically in sort of the image as recorded, the video as recorded of the world. That's the coordinates of the eye position refer to the position in that video frame, so to say. So then you can walk around and you can keep eye tracking, not in real world coordinates, of course, but at least in coordinates that move along with the participants, so to say. And some eye trackers are completely uncalibrated. That means that you just have completely random, well, not random, but arbitrary units for the X and the Y coordinates. An example of that is, for example, the dual Contingency eye tracker is a very old-fashioned type of eye tracker that outputs voltages corresponding to the X and the Y coordinates in arbitrary units. And if you then want to do like EEG, essentially, and then if you want to do something with that, you have to calibrate it. You can, of course, but at the basis is our uncalibrated coordinates. And the same thing is sometimes true of eye trackers that are used for vestibular testing, for example. That neurologists often use a kind of headset that they put on the head of the participant or of the patient, potential patient. And then they're looking, for example, at pathological nystagmus, which are kind of a particular kind of eye movement that everyone makes if you're looking out of the moving train, for example. Your eyes also do that, tick, tack, tack, tack. But normally we only do that if there is something moving. But people with neurological condition may also show those kinds of eye movements spontaneously, pathological nystagmus, and that is also then sometimes measured with this kind of eye trackers that are essentially uncalibrated, because the only thing that matters is the pattern of the movement, and not so much what they're looking at, so to say. So those so much about the y coordinates, and usually there's also a measure of pupil size and also a time series. So here you see that at the top, and you see that there's these gentle oscillations of pupil sizes. Gentle oscillations of pupil sizes, also interrupted by blinks, of course. And that's kind of what it looks like. And here pupil size is recorded in arbitrary units by the eye tracker that we use, the iLink. I believe that the Tobii will give you actually pupil size in millimeters of diameter. So you have to imagine that in order for the eye tracker to know how big your pupil is in natural units, in millimeters of diameter, it needs to also know how far the face is away from the camera, because otherwise it doesn't know how many pixels in the camera correspond to 2 millimeters, basically. So some eye trackers, such as the Tobii, and also eye tracker that we recently got, the gaze point eye tracker, they have that kind of sensor, and then they do some internal calculation that is probably far from perfect, but at least it gives you some unit, some measure in millimeters of diameter. All right, so that is basically what the eye tracker gives you. And usually there's also an event log. So what does that mean? Well, it means that you have some kind of way to indicate to the eye tracker what happens when, right? So that you can say, okay, now the trial starts. Now the target stimulus is presented. You can send messages usually indicating what variables live in your experiment, those kinds of things. So a little bit like for those of you who are familiar with EEG, then they have the concept of triggers, where a trigger is essentially a byte, a number that serves the same purpose, namely knowing where in the trial you are. And for eye trackers, usually there's a text-based format, but the idea is the same. So there's the eye tracking data at the end of the day is a combination of information about the eye, namely the position and the size of the pupil and the timestamp, and sort of textual information with where you are in the trial. Almost all eye trackers do it like that. Timestamp messages. But
Maybe,
what makes it a bit...
If I'm allowed to add a bit, because this is something that is very obvious to Sebastian and I, but for the rest of you, if you think about the structure that we made in OpenSesame of a trial, then it makes sense, right? Because we do, in addition to collecting response time data, we can also sync it to eye tracker, to EEG, and so on. And we need that kind of like consistent epoch of this is a fixation dot duration. This is when we show the stimuli. This is when we show the blanks. This is the window of recording time. So each trial consists of the same thing, so that when it's sent to the eye tracker or to the EEG system, there is this kind of like consistent event log that we can arbitrarily aggregate or compare across conditions later on.
Yeah, exactly, indeed. So you need to indeed, well explained. So in general, almost all eye trackers work like that. But what makes it a bit tricky is that eye tracking is not standardized. So all the log files have a different format. This means that if you have in the iLink that I often use, it has a particular kind of text file format called an EDF that you can convert to an ASC file. And they have some kind of conventions, right? And then you have to think of like basically that every message starts with a number corresponding to the timestamp and blah blah blah. It's a specific kind of format, but it is specifically designed for the iLink. And other eye trackers have a different format. And that means that if you analyze data from different eye trackers, you're essentially forced to, at least in the basis, when you process the data file up until into some kind of data structure that you're comfortable with, you have to do that differently for every type of eye tracker. It's really unfortunate. There are different sampling rates also. So the iLink has 1000 Hertz. I think Vishnu said that your Tobii has 250 Hertz. Those are very high resolution eye trackers, so they sample very fast. Real research grade eye trackers, basically, that also allow you, for example, to see during a psychetic eye movement, which takes maybe 60 milliseconds, how the eyes move, basically, right? So then you have this very tuck, it seems like an instantaneous movement, but it actually really takes maybe 60 milliseconds. And then if you have a 250 hertz Tobii, you have a sample every 4 milliseconds, meaning that you still have about 12 samples that indicate the trajectory of the eye during that very fast eye movement. So that's nice. And other eye trackers like the cheaper Gaze Point that we recently bought, they have a 60 hertz eye tracker, a 60 hertz sampling rate, which for most purposes is fine, but of course is much lower. There are different software development kits or SDKs. The software development kit is basically the software library that allows you to interface with the eye tracker. So, you know, the eye tracker has some software running that collects the actual data. And that software communicates with other programs in a particular way. And that is the SDK, the software development kit. Unfortunately, that is also different for every eye tracker. And then there are a lot of technical idiosyncrasies that are different between different eye trackers. Like, just to give you one example, if you look here on the right side, you see that there is a trial sequence. This is of the eye tracking template in OpenSesame. And you see that the trial sequence starts with the thing that is called PyGaze drift correct, and then PyGaze start recording, and at the end, PyGaze stop recording. Now, the start recording and the stop recording are kind of obvious, right? They indicate to the eye tracker, okay, now you actually should start collecting eye movement data. And then at the end, you should stop again. That is applicable to most eye trackers, but not even to all, because some eye trackers, just as soon as you turn them on, they start collecting data, and there's not really a concept of starting or stopping. And then you have this drift correction, and the drift correction is basically a trick where you ask participants to look at one dot on the screen, and then they look at that dot, and then you sort of do a slight recalibration, because you may actually really ask them to fixate, let's say, location 0,0, but then you note that the recording actually says they're looking at location -100,0. Now, and then you think, okay, that means that the calibration is a little bit off. So I need to correct that. I need to sort of shift the calibration a little bit such that it is aligned on the fixation dot again. A slight sort of recalibration that you do pretty quickly on every trial. That is what the drift correction does. Now, how does that relate to the technical idiosyncrasies? Well, first of all, not all eye trackers actually support that. The iLink does. And then the iLink has the technical idiosyncrasy that you need to do that before you start recording, because otherwise it will crash. So then you have the situation that you may design an experiment where you do a drift correction, say, after you start the recording. And for your Tobii, that may work fine. But then you try that on the iLink and it will crash. So those kinds of technical idiosyncrasies. And there is no standard analysis pipeline. And this probably for most people is the most tricky thing, because that is where a lot of technical expertise is required. So there have been attempts at standardization, though, to make things a little bit easier. And we're also going to make use of that today. So when it comes to building experiments, which we will focus on, there in OpenSesame, you have PyGaze. And PyGaze is a Python library and a set of plugins for OpenSesame that sort of provide a high-level abstraction of an eye tracker that works the same, or should work the same, some technical idiosyncrasies aside, for all different eye trackers. And this means that we can now work with PyGaze, and then ideally, but that apparently doesn't work currently, should work with your Tobii, and it will also work with the iLink, and it will also work with OpenGaze, other kinds of eye trackers, because PyGaze hides all these idiosyncrasies from the user to the extent that that's possible. So that's one example. Another example is IO Hub, which is a Python library that is used by PsychoPy for more or less the same purpose, that also attempts to provide an abstraction layer over the eye trackers. When it comes to analyzing data, there are a few Python or a few libraries that attempt to make this easier. There's Gazer, which is a nice library written in R by Jason Geller for analyzing eye movement data. And my own Python library is called the iLink parser. But these provide some degree of standardization, but still they are far from comprehensive. Yeah, are there questions actually at this point about eye tracking or the data analysis or setting it up? No? All right. Now, if you start eye tracking, then you of course have a setup. And what is the setup? It's just, the computers in the lab, basically. And then an eye tracker setup, generally speaking, consists of an experiment PC. And that is the PC that runs the experiment, obviously. So that's the PC that has OpenSesame installed and is running the experiment. Often, but not always, there is a separate PC that is doing the recording or the data acquisition. And that's the one that's connected to the eye tracker. So if you look at the picture on the right, you see what is quite a typical setup. So you see that here, there is one monitor that the participant is clearly looking at. You also see actually that the participant is wearing an EEG cap, right? So they're apparently doing combined EEG eye tracking, but that's not, we are not focusing on that, right? But that's why he's wearing a cap. But in any case, this monitor is connected probably to this PC right here, and that is the experiment PC. And then we have this computer, this laptop right here, and that is the recording PC, and it is connected to the eye tracker. So the eye tracker, the iLink is this device standing here, and that is connected to the recording PC. And then there is a cable basically running between these two PCs, between the iLink PC and the recording PC and the experiment PC. And that means that the experiment can tell the eye tracker to log certain information, such as when a trial starts. And conversely, it can also ask the eye tracker information about the eye, such as what the current eye position is, etc. So there's a bidirectional communication going on. And why use actually two separate PCs for that? The main reason is just one of performance, I think. So that especially if you eye tracking, if you have a very high temporal resolution eye tracking, it takes a fair amount of processing power. Nowadays, you could do it on the same PC, but historically, it used to be better to do that separately. Another example is that this way, you can actually use one computer to monitor the signal, so you can actually see whether the recording is going well, and then use the other computer to actually do the experiment. So you basically can monitor the data quality as it comes in, which is very convenient. For some eye trackers, the experiment and recording computers are the same. So for example, the gaze point eye tracker that I was mentioning that we recently bought, it basically, the recording PC is just a program that you start on the same computer as the experiment PC. That works. The downside is that it makes it slow and that you cannot actually monitor data quality while the participant is doing the experiment, because the monitor is of course just occupied with the experiment. And I have to say, for the Toby, I think it's like that as well, right, Wisnu? Or do you have a separate PC?
Yep, so it's plug and play. Well, supposed to be plug and play. But
it's one PC that does it all, so to say. You don't have the concept of a separate. Yeah. Okay. Yeah. So, but even if it is all running on one PC, then you can still think of it as not an experiment PC and a recording PC, but as different pieces of software that are simultaneously running on the same computer and communicating with each other. So let's focus a little bit on PyGaze. PyGaze is a Python library for eye tracking. That's what we're going to use today for the tutorial. It supports different brands of eye trackers. The quality with which it supports that varies a lot from eye tracker to eye tracker. Mainly because, of course, every eye tracker requires its own implementation, someone to actually do that. And that is not always trivial to actually to do that well. The iLink is supported very well. The gaze point now is supported pretty well, because the Toby I thought was supported quite well, but I'm now learning that that is problematic. And it integrates with OpenSesame as a set of plugins. So, and we are going to use PyGaze to implement a fancy gaze contingent self-paced reading experiment. But we'll start slow. Oh, I wanted to actually explain, but I'll do that a bit later. Then I wanted to have a slide that actually shows the individual plugins to explain what they mean, but I will do that. I will open OpenSesame and show you through that route. So that to make it a bit more concrete. So yesterday we talked about online experiments, and then a question that pops up, of course, is can you actually do eye tracking in a browser? The short answer is not really. If you want to do a high resolution, high quality eye tracking, honestly, you need to have a proper laboratory setup, right? I mean, high quality eye trackers, they are thousands of euros in my currency, and up to, I think the iLink is like 30,000 or something, and even the low-cost gaze point is like 800 euros. You need a proper laboratory setup. And one reason for that is actually not because because they're for-profit companies selling a product that is not mass marketed, but also because eye trackers are not regular cameras usually. They are infrared cameras, near infrared cameras, and they also come with infrared LEDs. And basically how they work is that these infrared LEDs, they are lights basically that are difficult to see because they're in the infrared spectrum. So they seem a little bit reddish, but most of their light is actually emitted in a spectrum that we can't see. And these lights, they shine onto the cornea, so onto the surface of the eye, and they reflect, of course. And then you get a strong, what they call corneal reflection. It's like a big bright spot in the eye, only in the infrared spectrum. And the eye tracker uses that as a source for the eye tracking. So basically it looks at this reflection in the eye. That's an integral part of the eye tracking. Now, in order to be able to do that, of course, you need A, infrared LEDs, and B, an infrared camera. And that's a special type of equipment that you need. And a normal camera doesn't have that. That's what it comes down to. But of course, you don't always need to be picky, and poor quality eye tracking can actually be done in a browser. I will show you an example in a bit of using the webcam. Then you need camera, of course, but then you can just use a normal webcam. And the best known implementation is a library called webgazer.js, a JavaScript implementation of an eye tracker based on a webcam. And it works with OS Web. I will show you in a bit. It is at the same time super impressive, I think, that it works, and kind of useless, because even though it works and it is impressive, the quality is so poor that it is doubtful whether you will actually want to use it in an experiment. But the technology is moving in that direction for sure. And I would be surprised if not in the near future, actually, eye tracking will be a normal part of webcams, and especially, of course, also phones. Whether that is desirable is another question, of course, but I suspect it will move in that direction. So what are we going to do for today? As I said, we're going to implement a self-paced reading task. There is no tutorial anymore because we've already done 2 tutorials now. I think you know the drill. You've seen the sequence, you've seen the loop, blah, 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 blah. Now it's time to be a little bit more hands-off and actually implement this yourself. But I will give you a few pointers. And the details of the task, of course, are up to you. So here is how I would approach a self-paced reading experiment. So this is what I call a trial sequence that I will explain to you. So this very elongated thing corresponds to something that is shown on the display. Of course, your display is not elongated like this, but just to make it a bit easier to visualize, let's say that this is a display. Then you start at the beginning of the experiment with the drift correction. That is a little dot that is on the left side of the screen in this case. And that is self-paced in the sense that you ask participants to look at it, and then you press a button in order to start the task. Then once the task starts, you present 2 fixation bars. This is something that psycholinguists like to do. they put one bar at the top and one bar at the bottom, and then they assume that participants will sort of look in the middle. I doubt they will. I think they usually will look at the bars. But the idea is that then you can put a letter in between, and the letter is not masked by the bars, basically. Now, and then after the bar, you show a sentence. And it is some kind of sentence that says, for example, the magic bunny reads Dostoevsky with malicious intent. And the participant has to read the sentence, and then when the sentence is read, you press a button to indicate that the sentence is done. And that's it. That's the task. So this is very simple, but it is an actual eye tracking experiment. Now, then, of course, to make this interesting, you need to have some kind of independent variable. This is up to you. This is your input, your creativity of how you want to do it. But you could, for example, have as an independent variable sentence complexity, right? So you could have something like the magic bunny reads Dostoevsky with malicious intent. It is a nonsensical sentence in many ways, but it is very simple because there are no subclauses, etc. And then you can compare that with the magic bunny, comma, who had malicious intent, or which had malicious intent, if you don't want to personify, read Dostoevsky, right? And then suddenly you have a subclause, so it will be grammatically more complex. And then you can say, I'm just making this up, right? But then you just say, okay, it will take more time actually to read the sentence for if the grammatical complexity is higher. That would be the idea, something like that. Be creative, right? You can also say, I want to vary whether the characters in the sentence are bunnies or they are human beings, and then look at that, whatever. Anything that actually measures that you can vary. And then the dependent variable in this context would be response time. That's it. This is the self-paced reading task. And my suggestion will be that as soon as we get to work, you focus on implementing this. And then after the break, we will take this to the next level by changing it to a gaze contingent reading task. And the main difference will be that it is not the case that the main difference will be that it doesn't end when you press the button, but it ends when you've actually read the sentence based on the recording of the eye. That would be the idea. But let's start slow. Yeah, and it ends with a blank when you're done. So how can you approach this? Here are some pointers to actually really get started. And by the way, all of these slides, right, they are also on the workshop site. So you can just download them from there and look at this again. So I would say start from the default template. Then at the start of the experiment, you add a PyGaze init plugin. Actually, now I was thinking where I want to introduce the plugins, but I'm doing that here now. I was a little bit confused about my slides. So the PyGaze init plugin, that is where you initialize the eye tracker. And this, if you actually connect it to an eye tracker, it would set up the connection, it would start the calibration, etc., etc. Exactly, thanks, Vishnu. But we are not sitting behind an eye tracker. So what you can do is put it in advanced dummy mode. This means you select as a tracker type advanced dummy mouse simulation, and then you can pretend like your mouse cursor is the eye position. That's all that it means. Then at the start of each trial, right? So you build a normal sort of experiment with a trial sequence and a block loop. And then at the start of each trial, you start with the PyGaze drift correct item, and that the participant needs to look at the drift correct item and press the spacebar in order to start. If you do it in mouse simulation mode, I'll already point that out because it's a bit finicky, then sometimes you have to actually sort of move the mouse a little bit in and out of the fixation dot to sort of simulate an eye movement towards the fixation dot in order for the drift correction to pass. Otherwise, it will kind of hang. Then we have the PyGaze start recording that actually starts the recording. And then you do the trial sequence, right? You do the thing with the sentence, etc. And then at the end of each trial, you do a PyGaze log, very important, because what that will do, it will send all the data from the OpenSesame about the experimental variables that live in OpenSesame and send them to the eye tracker. And that this is important because it means that your eye tracker has all the information. And if you don't do that, you will end up with a situation where you have the OpenSesame log file, the CSV file that we haven't actually looked at yet. We're going to do that next week. but there's an OpenSesame, of course, maintains a log file. And then you would have a separate eye tracking log file. And during the analysis, you will have to sort of match them together. That is quite inconvenient to do. And if you just make sure that the eye tracker has all the information, then during the data analysis, you only need the eye tracker log file to analyze stuff. And then you stop recording again. That's it. That would be the logic. So let's go to work, I would say. But shall I first take also this moment to show you actually the WebGazer thing, just for fun, that you can see how that works, because I think
sure.
you're interested in that. All right. Up. All right. So I go to the documentation side. I'll zoom in a little bit. And then under manual, you have a lot of stuff in general, but also a lot of stuff related to eye tracking. So here you have the eye tracking section, and you see that WebGazer.js online is this button, that link. Now I click on it, and then you have some information mainly about how you can include WebGazer.js in your own experiment. And you can also download an example experiment for how this works. So here's a link to an example experiment. You can play around with that. It's quite funny to do actually. But I think for our purpose, it's more useful to just actually start the experiment so you can see what it looks like. All right. So now I'm starting it. Let me actually configure. So I have my webcam in front of me now. You don't see that because you're looking at me through a different camera, but I also have a webcam. So, oh, oops, wait. I went a little bit too fast. Up. Let's restart it. Clear the calibration data, yes. So now you see it is actually picking up my face, right? And now this is magic to me, but what it is doing now is following my eyes with the logic that every time that I click somewhere, I'm looking at it. And it is automatically calibrating based on that. In a way that I don't understand. It's a very different kind of machine learning based eye tracking technique that doesn't resemble traditional eye tracking, but that's something like that is what it does. So, and now you see the red dot corresponds to my eye position as it is being estimated by WebGazer. So I'm looking at these dots, clicking on them. You have to forgive me, it takes a few clicks in order to get this to calibrate well. Right now, you see that the red dot is very closely following my mouse. This is kind of cheating, right? Because now it is being calibrated based on the assumption that I'm following the mouse. And as such, it is pretty well able to know where I'm looking. And the proof of the pudding, of course, is when I am no longer moving the mouse. So now I'm calibrated. The red dot is my eye. And now I'm going to look at the top left, top right, bottom left. Can you see this? Top left, top right, bottom left. Can you confirm that you're all able to see this actually?
Yeah, it's actually
Okay.
very impressive.
So this is
Can see, Mr.
good. So you see how this is at the same time, and now I'm sort of off. I moved, and now the thing is off. You see how this is at the same time impressive and useless, right? Because I find it amazing that it is able to actually tell approximately what I'm looking at based on this regular webcam that's not even that close to my face. At the same time, I don't think it will do much more than just tell you approximately which quadrant of the screen you're looking at. I think that's about the accuracy that you get. And even for that, you need a participant who is super willing to actually keep their head still and really participate, right? I mean, if you try this with most people, of course, they will be like, oh, and then will not work. So, but anyway, that's WebGazer. Okay, so So I would say, let's get to work on this self-paced reading task that I suggested. Here we have the workshop site. Here under eye tracking, you have the link to the slides that I just showed you. And I'm not actually going to walk you through the steps now, step by step, but I'm going to stay here while you work on it. That is the logic. Does that sound good, Vishnu? I don't think we need separate breakout rooms for this right now, do we?
No, yeah, and I'll at least for those of you who are staying with us on site at the campus, I'll do what Sebastian does, but on site.
Excellent, excellent. All right. Good luck with that then.
Yeah,
let's get to work.
So the simplest start would be to just open OpenSesame, and you know, but the drill by now. So you start with a big sequence, and you put a loop, one loop,
Exactly.
and then another sequence for the trials, and then you put the trial sequence. You implement the sequence that Sebastian showed you. So
exactly, yeah.
All right.
So and and ask, right? Because the assumption is that you work on this and then you get stuck, and then you ask and we help, and then you get stuck again and we help again, right? So don't try to solve everything on your own, but just don't hesitate to ask us. And the reason for not giving you a tutorial is to encourage you to actually get into more independent thinking, so to say, as compared to when you would just follow me along. So,
and to just saying out loud, so like if you do not think too much about the independent variables, so like sentence complexity could be one example, but I can also think about other things like, is it the word or non-word, grammatical or not grammatical, capitalized or not capitalized, you know, pick some easy things. So
exactly.
Yeah,
and in order to implement the basic experiment, you wouldn't even need an independent variable. For the basic experiment, all you need is a sentence to show. But of course, because a good experiment does have an independent variable, I encourage you to think of one, actually.
And for those of you who are on site, you can also ask Farah.
All right, I will briefly actually get up, so you don't see me in the camera, but I will be here.
And I'm also turning my cameras off, but I'm here. Like for those of you who are on site, you can see me that I'm actually here. But for those of you who are following from home, just send me a message if you need anything. So I'm just sharing this this part where you explain the trial structure. So it's easier for everyone.
And I just posted in the chat also a link to the manuscript I meant before about sort of a manual for doing pupillometry. And many of these things translate also to general eye tracking, because pupillometry, of course, is a subform of eye tracking.
So just to remind again to everyone, so what we're doing now is to trying out building our own experiment, a simple experiment that Sebastian just explained. The trial structure, I show it to you on the screen. You're seeing the trial structure, but to get into the trial structure, just remember that in an experiment, a trial is something that you loop over, so you need another component for that, and so on.
Exactly. And that part is the same as before. So what you need is a sequence item that will actually contain the events of a trial, just like you can also refer back to the tutorial of yesterday where we did the same thing, except that there were different things in the trial, of course, but there was the idea of the trial sequence was the same. And the trial sequence is then in a loop that repeats the trial multiple times. We generally call that the block loop. Inside the block loop, that is where you define your variables, in this case, of course, your sentence. And if you have an independent variable, then you would add a different column for that, say complexity, high or low, so to say. And those are the building blocks of your experiment. In the meanwhile, I'm also building the experiment myself here on my own computer. And then in a bit, I will show you my solution, so to say. And then you can see how that works. And in the meanwhile, don't hesitate to ask, of course, if you get stuck, because that's why we're here.
So as Sebastian mentioned before, start with a default template. So once you open the OpenSesame app, so you have an option to get the multiple templates. Some of you might be driven to just select the eye tracker template, but don't do that. Instead, choose the default template, and the default template is empty. And you fill in the default template with things that we have been learning over the last 3 days. The sequence item, the loop item, and so on.
Yeah, exactly.
My question is, because we are using the side gaze, initiating side gaze, should it be like inside the experiment or before experiment, or
so there are maybe, can you scroll down a little bit, Vishnu, to the next slide?
The next slide.
So here's the general structure of the experiment. So you, at the very start, so basically just as the first thing in the experiment, you add a PyGaze init item.
Okay.
Then you know what? Actually, let me. No, I'm not going to share my screen
Not
because I
yet.
think you should discover that yourself. But the
Yeah.
idea is, we start with the PyGaze init item at the very start of the experiment.
Okay.
Then we have a block loop, right? Inside the block loop, there's a trial sequence. And inside the trial sequence, there's a series of events. And the first event should be the drift correction. The second event should be the PyGaze start recording. The last event should be the stop recording. Well, the one to next to last event should be the PyGaze log. And in between those eye tracking things, there should be basically the trial itself. So actually showing the sentence, the fixation bars, collecting the response, etc.
Yeah. Okay.
Yeah.
Good, thank you. Bisa Mbak, bisa take it easy.
And also, while you're actually at some point going to draw the sentence, you will see that if, of course, you want the sentence to start at a particular location, you want to you have to play around a little bit with the settings of the sketchpad, because by default the sentence will be centered, which means that depending on how long the sentence is, of course, it will start at a different location. And then the trick is simply to actually uncheck that the thing that says centered in the sketchpad. So it's also a little bit of an exercise in learning how to do those kinds of things.
So I see that people here are getting confused quite fast. So as a suggestion, I would say focus first on the trial sequence, the trial structure. Once you get the trial structure, so the trial structure is identical, well, not identical, it's comparable, very comparable to what we did yesterday and on day one. So a trial consists of a fixation dot, something that you show to participant, and something to collect a response. So focus on that first. Once you manage to mimic something that looks like something that we had yesterday, play around with it. Once you have it done, and then start adding the eye stuff, the drift correction. Yeah, right. So do you agree with this, Sebastian?
I do. And now, if you say that some people are getting stuck with this, why don't we actually create a breakout group? And then the people who want a little bit more hands-on guidance follow me to the breakout group, and then I basically do what I did before. I show how to implement it. And those people who feel like, okay, I want to try it myself, stay in the main room, and you just help them out.
Yeah, sure.
Does that sound like a good idea?
Mm-hmm. I'll make a big question.
All right. Then we can sort of scaffold, as they call it, the level of the workshop to what works best for everyone.
So I have a breakout room now, so Sebastian will go to that breakout room.
Mm-hmm.
If you want to do a hands-on tutorial, you can go to that breakout room. If you want to work on the experiment yourself, you can stay here in the main room. And if you want to ask me around, I'll stay in the main room as well.
Yeah. All right. I'm going to the breakout to the breakout room now. Those of you who really want to sort of a walkthrough, follow me to the breakout room.
Saranku sih coba sendiri dulu.
Sorry, Mas Ustaz.
Oke, Junior gimana? Buat yang teman-teman yang di sini, jadi teman-teman yang di sini itu maksudnya yang di Zoom. Ada beberapa yang bertanya ke saya nih. Jadi hari ini untuk eksperimen yang hari ini tidak ada tutorialnya di OpenSesame. Jadi nggak ada di website. Seperti kemarin kan, kalau nggak bisa ngikutin bisa lihat contekannya di website. Tapi untuk yang hari ini nggak ada. Nah, jadi saran saya sih tadi, mulailah dengan si trial structure yang tadi ditunjukkan Sebastian. Jadi yang tadi saya share screen itu loh, saya udah tutup Bang. Mulailah dengan trial structure seperti yang di halaman sebelah kiri. Dimulai dari default template. kalau kemarin trialnya itu isinya adalah gambar anjing atau gambar kucing atau capybara dan suaranya, dan collect response dan log. Hari ini trial structure-nya isinya adalah drift correction, fixation bars, dan sentence, dan blank. Jadi kira-kira ada 4 sketchpad. Gitu. Lu save di mana?
Mas,
Ya, ini ya.
pertanyaanku itu ini harus kayak sama gitu ya tampilannya, kayak harus ada bar warna abu-abu.
Enggak.
Oh,
Bar ini cuma, oh ya, bar abu-abu ini cuma visualisasi.
oke.
Walaupun kalau misalnya kalian tahu si sentence-nya ini akan muat di bar, nah ini pakai trial and error juga karena sentence-nya bisa panjang, bisa pendek gitu kan. Kalau kalian tahu si sentence-nya ini bisa muat di bar, mau pakai kotak gitu, gambar kotak dulu di OpenSesame nggak boleh juga. Mungkin jadi lebih kelihatan juga.
Oke. Terus setelah kita buat ini, maksudnya kan ini kayak static gitu kan. Terus kan ntar harapannya mestinya jadi dynamic gitu ya, dimasukin ke loop-nya gitu. Jadi independent variable, contohnya mungkin kalimatnya bisa setiap trial kalimatnya berubah gitu kan. Terus yang berubah itu hanya kalimatnya atau yang correction-nya juga berubah atau fixation juga berubah?
Yang berubah ya dalam hal ini cuma kalimatnya, jadi cuma si sketchpad yang ketiga ini. Jadi nanti di block loop isinya adalah yang kubayangkan adalah isinya cuma dia kalimatnya apa yang akan ditampilkan di dalam sketchpad, dan apakah kalimat ini kondisinya apa. Misalnya kalian mau buat kondisinya gramatikal atau nggak gramatikal. Jadi isinya cuma 2 kolom.
Oke.
Gitu.
Hi, we're back. So we in the breakout room we've been together working on the basic experiment, and I will share with you also what we created there. So just for those of you who the chat is not shared between the two rooms, right? So I have to send it again, I assume. Yep. And if not, I will have to. You have it twice. Okay. So it's almost time to take a break. Shall I quickly share my screen and walk you through how I implemented this? Then we can take it from there. Vishnu, are you with us?
Oh, Vishnu is still explaining things to people in here, but yeah,
okay.
Go ahead.
Okay.
Let me remind the other people that you're going to start explaining things.
Okay.
1 second.
I'm here. So, Sebastian, I'm here.
Mm-hmm.
So, Farah told me that you're going to show the implementation that you have.
Yeah.
Yeah. So maybe that gives some kind of like an overview of how it's supposed to look, because I get questions like the drift corrections, the fixation dot. Do we need two of them? So things like that. So
exactly. So
I'll let Sebastian show it to all of you.
Yeah. So before we take a break, I think it's nice to actually make sure we're all on the same page, and then also after the break we can pick it up with doing the case contingent implementation. So now you're looking at my screen, right? So how did I implement this? Let's actually start with the trial sequence. So click on the trial sequence, and I will focus with the things that are not, start with the things that are not really related to the eye tracking, just the experiment as such. So the fixation bars are the first event of the experiment, right? And you see that what I did is I simply drew two horizontal bars a little bit on the left side of the screen. As specifically, they're focused on the coordinate -400, 0. So that's kind of the origin of our experiment. So we're not, our sort of fixation point is a little bit to the left. And why? Well, so that the sentence can run through the right and we still have enough space. That's the idea. And this is shown for 500 milliseconds. So I put it at 495, right? 500 milliseconds, few milliseconds down. So that's how long this is shown. The next event is the sentence. And you see that I drew the sentence here. And I drew it actually at the point -400, -16. And then I disabled the center. You can see what happens if you enable or disable the center. And if you disable it, this -400, -16 will actually correspond to the top left of that sentence. So that means that it is nicely sort of in between the two horizontal bars. You also see that I didn't actually literally draw the sentence, but I put in between square brackets the word sentence, meaning that I'm assuming that there is a variable that is named sentence, and I'm referring to that with this square bracket notation. That is what I'm doing here. Now, that sentence is shown for 0 milliseconds, which means that we move on immediately to the keyboard response. The keyboard response just collects, it waits until you press a key. And the only thing that I changed here is that in the allowed responses field, I put space to make it such that all other keys except for the space bar are ignored. That's what I'm doing. After the keyboard response, I have a logger item. The logger item simply writes everything, but it writes everything, all the data, but only to the OpenSesame log file, not to the eye tracking log file. And therefore, after the logger, I have another item, the Pygaze log, which is quite similar to the OpenSesame log file, but it also logs everything to the Eye Tracker log file. And you see, you can type here, you can type random things if you want, and they will go to the log file. But you can also say, okay, I automatically log all variables by ticking this box. And that means that to the Eye Tracker log file will have one line of text for every variable that lives in OpenSesame. And that is quite convenient because it means that you have all the information that you need in your Eye Tracker log file. But now I'm actually switching incidentally to the eye tracking stuff. I'm mixing things up. All right, rewind. I explained from the fixation to the logger. Those are the things that are related just to the experiment as such. Now let's switch to the eye tracking. Where does the eye tracking start? The eye tracking starts with the Pygaze init item that is at the very start of the experiment. And it initializes the connection to the eye tracker. And it also starts a calibration routine if that is applicable to the eye tracker. So here you see that the main thing that you need to do is select the correct eye tracker. In our case, the correct eye tracker is the advanced dummy. But of course, it depends on the eye tracker that you want to use. But the advanced dummy allows us to pretend like the mouse cursor is the eye position. And this allows us to implement some gaze contingent things, even though we don't actually have an eye tracker to test this on. That's the idea. Depending on the eye tracker that you use, you can also specify some other things that you can do here. You can also say, okay, I want to calibrate the eye tracker, etc. Okay. Once this is done, we've set up the eye tracker. Then as part of the trial sequence, the very first thing that we do is a drift correction. So actually rewind. The Pygaze init does a calibration. A calibration routine means that a bunch of dots, usually 9, are shown at different parts of the screen, and the participant is asked to look at those dots. And based on this, the eye tracker determines a mapping essentially between the image of the eye and the position on the screen that the participant is looking at. Based on this mapping, there is a calibration is done, and it allows the eye tracker to give you coordinates in XY coordinates in screen coordinates, basically. But over time, this calibration usually gets a little bit less accurate because the participant moves or things change a little bit. The Pygaze drift correct takes one dot and does a slight sort of recalibration based on that one dot. Then you have to say, where should this one dot be positioned? I positioned it at -400,0 because that is our origin in this particular example. And what that will look like, I will show it in a bit, is basically a dot is presented there. You have to move your eyes there and press space to perform that drift correction. Then we have the Pygaze start recording. That just says to the eye tracker, okay, now start collecting data. And it also writes a little bit of a message to the eye tracking file saying that the trial has started. By default, that message is just start trial, but I added a little bit of another thing to it. Between square brackets, I put count_trial sequence. That refers, of course, to an experimental variable, right? Because it's between square brackets. And the experimental variable is a counter for the trial sequence item that is automatically created by OpenSesame. Every item has a variable that is called count underscore the name of that variable. And it just keeps track of how often the name of that variable, count underscore the name of that item. And that just keeps track of how often that item has been presented, executed. And so basically it is a trial counter, right? So it means that the first time it will be start trial 0, start trial 1, start trial 2, etc. All right, well, then we have the fixation bars, the sentence, the keyboard response, the logger that I just covered. Then the Pygaze log that I also just covered that writes all the information to the log file. And then we have a Pygaze stop recording item that actually stops the recording. All right. And also writes a little bit of a message to the log file to indicate that the recording has stopped. Okay. And then let's see if this works. I know it works because I just tried it, but let's show how it works. So I click on the run button. Up. Here's the drift correction. The mouse is my eye, so to say. So I move my eye to the drift correction. I press space. The weather is always good in Indonesia. That's one of the sentences that I defined. Press space to accept it. Next drift correction, press space. Start, lobsters are soft and furry. Press space. Move back to the dot. The weather is always good in the Netherlands. Press space. Up. Bunnies are soft and furry. Press space. And those are all the sentences that I defined. And where did I define the sentences? I forgot to mention that. I did that, of course, in the block loop, where I had one column with sentence that actually has the sentences in it that you just saw. And then my independent variable was sentence validity, where some sentences are good, right? The weather is always good in Indonesia, and bunnies are soft and furry. That makes a lot of sense. But the weather is always good in the Netherlands, and lobsters are soft and furry. That doesn't make a lot of sense. So that is what I manipulated here. All right. So that, in a nutshell, is the solution, so to say, to this self-paced reading task. Let me pull up the chat. Are you all with me? Does anyone, I want to take a break after this, short break, but before we do, who has questions about this, or is this clear? And for those of you who didn't manage to actually implement it, I put the experiment file in the chat, right? So you have -day3.osx in the chat, and you can download it and then work from there after the break. Can you give me a thumbs up if you're good? All right. All right, Arjo, I see that you raised your hand. Is that an indirect thumbs up, or do you have a question?
I have a question.
Right.
I already did quite similar to your experiment, but whenever I try to test it, you just put the fixation point, and whatever I try to do with it, it doesn't make any response. It's just making a beeping noise. I don't know what happened there.
So it just hangs on the drift correction, basically. Is that true?
Yeah, it's
okay. Let me show you. I know this is a bit confusing, but the solution is really simple, actually. So right now it is showing the drift correction dot, and I have my mouse. I have to move it to the drift correction to sort of simulate an eye movement to the dot, so that Spygaze knows. And then if I press space, it will move. The weather is always good in Indonesia. But if I don't do this, and now I just press space bar, it will just give a sort of annoying beep noise saying that it didn't work.
Okay.
But then if I move my mouse there and I press space, it will work again.
Okay.
That's probably what happens in your case, right?
Yeah, but I also try to move the mouse to the fixation point, but it's also still making that beeping noise. So
okay.
And this is also assuming that you chose the right eye tracker. In this case, it's the advanced dummy.
It is the advanced dummy mode. And another thing, yes. Indeed. And another thing, are you using Mac OS?
Yes, Mac OS.
Yes. Okay. There's an issue on Mac OS with the alignment of the mouse coordinates. I don't know exactly where it comes from. It has something to do, I think, with the display scaling. If you select a different backend, select the legacy backend, I think it will work.
Oh, okay.
Okay. I will running into an issue there.
Okay. Thank you.
Okay. Yeah. So my suggestion is to take a 30-minute break and reconvene at a 3:15. And now I have to do a mental calculation. 3:15 for you. Is that correct? And then we pick up with implementing a gaze contingent version of this experiment, which sounds intimidating, but it's not. Is that okay? Does that sound good, Wisnu? Yeah. All right. Then I will see you. I will see you in 30 minutes, 3:15. All right.
So people have been telling me that it's a 30-minute break. So yeah, let's have a break.
Yep.
I'll see you in 30 minutes and give some time to tinker with your own projects.
when we want to put a picture, then it will be like in the center or something like that?
If you would use, well, so it depends on the specifics of the how you present things, of course. My starting point is always to put the fixation dot in the center, unless there is a good reason not to do that. And for most pictures, I guess you would put the picture in the center, so there would not really be a good reason to put the fixation dot somewhere else. And in the example of the sentence, the only reason to put it on the left is so that we have a little bit more, right? And the people start at the left, and then they have you have some space on the display to actually really present the long sentence.
All right.
So there is no big theory or anything behind that, right? You just need to do what works well and what looks good for your particular situation.
Okay. Okay. Thank you.
Yeah. All right, Wisnu, do you think we're good to go?
Yeah, I'm still helping people around. So some people are not having weeks, but that's a good indication that they're excited about, trying out the experiment.
Okay, so then let's pick up where we left off. We now implemented this very simple experiment, right, where you read the sentence, and then when you're done, you press the space bar. But what is very often done in these kinds of experiments is to add something in the experiment that depends on what you do with your eyes. And that is called gaze contingency, right? Contingency just means that one thing depends on another, means that one thing depends on another. And gaze contingency means that something in the experiment depends on what you do with your gaze. And what I wanted to suggest, actually, I explained it a little bit poorly in the beginning. But what I wanted to suggest to implement is something that is called a boundary paradigm. And it goes like this. So you start in the same way as we did before. So we have a drift correction, and then we have some fixation bars at the top, and then we present the sentence. And then what we do is we show this sentence until something happens. And then you can choose whether you want to make this complicated for yourself or whether you want to make it easy. In the easy situation, you present this sentence until the participants make a psychetic eye movement. So what's a psychetic eye movement? It just means it is the kind of eye movement that you very rapidly shift your eyes, right? So for example, when you go from one word to the next word, then your eyes sort of rotate really rapidly, and that's a psychetic eye movement. And in Pi gaze, you can detect the psychetic eye movement with the so-called Pi gaze wait item that basically waits until participants make a psychetic eye movement. And then as soon as that happens, you replace the sentence by another sentence that is slightly different, right? So for example, you can say, the magic bunny reads Sartre with malicious intent. And then as soon as they make an eye movement, you say the magic bunny reads Pagnol with malicious intent, both of which are French writers. And then when they're done, they press the space bar. In the hard condition, you actually do this until you do it in a slightly more complex way. You actually wait with replacing the sentence until participants fixate on the fourth word. So the logic here, this is called the boundary paradigm. Let me walk you through the logic here. So participants start by reading the, right? And then they make an eye movement to magic, and they make an eye movement to bunny, and they make an eye movement to reads. Then as soon as you fixate on the reads, you're about to make an eye movement to Sartre. And normally what you would do if you're reading is you're already sort of have a preview of the thing that you're going to read next. And then you actually make movement, eye movement. Now in this boundary paradigm, what you do is that you basically replace this preview by something else. So as soon as participants are here with their eyes and they're about to make an eye movement, they've already kind of anticipated that you're going to see Sartre. But then what happens, they make the eye movement that actually land on the word Pagnol, and then with malicious intent. And then the idea here is that if you do this, then you can make a distinction between sort of a what they call a parafoveal preview effect. So how much information you already take up from the words in your periphery before you actually read them, actually fixate them. You can distinguish that, dissociate that effect from the sort of the normal reading effect that you get if you just look at the word, right? So if you initially have something that is super unexpected, for example, and then you land on something that is really expected, or the other way around, you get sort of, you can see kind of interference effects on the reaction time. That's a little bit abstract, but what can I say? Yeah, say for example, here the Magic Bunny reads Sartre. If you would replace that by another French writer, it doesn't change much. They're both French writers, and it doesn't interfere that much. But if you would if you replace it by something that is really unexpected, like what would be very unexpected? Something that is not a writer reads the paper or something like that with malicious intent, then you actually change really the category of the word that participants are going to look at, and then you would get sort of an interference effect. Those are the kinds of questions that this paradigm is designed to address. But for the purpose of implementing it, of course, the research questions don't really matter, mostly about the implementation. And then the logic is monitor eye position, the Magic Bunny reads, oh, change the sentence, Pagnol with malicious intent. That's the idea. And then they press the spacebar. So that is the hard implementation, the more difficult implementation. And that's how it's usually done. If you want to keep it easy, then you do something that's a little bit less cool, but you just say, okay, as soon as they make an eye movement, you say, the Magic Bunny reads Pagnol with malicious intent. And we can do both of these things. And then at the end of the day, it's blank. I hope that this is kind of clear. Does this make some kind of sense?
So maybe something that's pretty obvious for Sebastian and I. In an experiment, typically you have a constant, something that you always want to show to participants. It doesn't change across trials. The fixation dots is a constant. And something that changes across trials. In this case, and that change, something that changes is a variable. In this case, it's not about the fourth word, but there is this rider that changes across trials.
Yeah.
So the idea is to change something in your sentence, and that could be on the fourth word or the 12th word or whatsoever. And that would be an indication on when you would change that sentence into something else. And then we're going to use this technology in Eye Tracker. It's called saccades. That's the jumping of eye movements, which we will simulate using a mouse in this case, right?
Yeah.
In which we will simulate using a mouse, and then the mouse will need to move until the fourth word in this sentence, in this particular example, before that sentence changes.
Yes.
So you will need to decide yourself whether it's a word in the sentence that will change, and you know, which word will change. Is it the fourth word, the second word, and so on?
Yeah, exactly. Okay, so let's also provide a few pointers for how to implement that. So you need two sentences rather than one, of course, and therefore you also need two sketch pads, a sentence 1 and a sentence 2. That is the main difference. And then in between sentence 1 and sentence 2, you need to have something that actually waits for a particular criterion, and that is where the difference between the hard and the easy sentences, that is where that difference is. So I will type it in the chat, and you have this. So you have sentence 1, and then you have something that waits, and then you have sentence 2. That is how you would implement that. Now, and then the question is, what is the weighting? In the easy condition, when you just wait until the first saccade, then the weighting would be a pi gaze weight item that is just built into OpenSesame. You will see it along with the other Pygaze items, and you can use that to have the experiment wait until the participants makes a psychetic eye movement. So that's really easy to do, but it is not so cool, right? Because it doesn't depend on where the participant looks or anything like that. It's just the first eye movement. The hard is that the wait is a Python script that analyzes gaze position. This is hard, basically. That's also why it's the hard assignment. And my suggestion would be that you decide for yourself what you want to try. If you want to try the easy, just to get familiar with OpenSesame, and because you don't really feel like you will benefit much at this point from looking at Python code, then that's what you will do and stay here in the main room with Wisnu. If you feel like taking on the hard part, then you follow me into a breakout room and I will explain that. Do be prepared for looking at some things that are pretty complex though. This is by necessity complex. So you don't fully have to understand everything, but if you are completely unfamiliar with programming, probably it will be so complicated that you will not benefit much. And then I would say, do the easy assignment. Does that sound good, Wisnu? Yeah? All right. So let's see, how are we in terms of breakout rooms?
The breakout room says hands-on tutorial, but
yeah.
I cannot rename it for some reason. So
that's okay.
I'll just leave it at that. So Sebastian will be in the breakout room if you're interested in trying the hard version of this task, then go ahead and join Sebastian. But if you want to try to implement the easy implementation, then you stay in the main room.
All right. I will see all of you in a bit, and I'm joining the hands-on tutorial breakout room now.
Sepertinya tidak ada yang join sama Sebastian.
Saya sih pengen join, tapi nggak boleh. Junior mau gabung ke tempatnya Sebastian? Oh iya, langsung cabut ya. Oke, buat teman-teman yang di sini ada yang kesulitan. Kayaknya koneksi di Kijang juga lagi turun.
Ya sorry mas, saya jadi ke sebelahnya.
Silakan loh kalau mau ke sebelah. Ada Farah juga.
Mas Wisnu bisa kirimin file yang contoh D1, D2 itunya OpenSesame-nya. Tadi kan Sebastian cuma kirim D3 hari ini aja.
Oh, D1 dan D2 sebentar ya.
Itu apa namanya? Yang Eye Tracker ini kayaknya nggak terlalu...
Karena ini juga baru buat saya sih. Baru dalam artian di kita pun sistemnya berbeda dengan yang biasa saya pakai. Oke.
Ya, soalnya juga kurang standar. Apa sih? Pokoknya kayak pas aja mau pakainya yang Eye Tracker, aku sih lebih tertarik yang D1, D2 aja.
Sebentar ya.
Yang agak
minus
butuh alat juga kan, dia butuh alat.
Dan kita punya alat.
Jadi, oh gitu.
Yes.
Ada berapa?
Eye tracker satu. Bukan benda murah, so. Ini ya sudah saya
Ada
masukkan
efek
di chat.
samping nggak sih? Ada
Enggak.
efek samping gitu, misalnya ibu hamil nggak boleh kayak.
Ini bukan
X-ray.
MRI, bukan.
Oh, bisa ya, aman ya.
Oke. Ini yang contoh untuk D1 dan D2.
Tapi kan ini nggak benar-benar online berarti kalau yang itu, yang eye tracker kan harus ke tempat ke lab kan?
Betul. Oke, saya sambil keliling-keliling juga ya.
Makasih Mas Wisnu.
Ya. Mungkin bisa lo kecilin. Oh ya, bisa. Oke, mungkin biar kebayang, saya kasih lihat aja kali ya untuk yang versi isi jatuhnya kayak gimana gitu. Oh jangan dulu, jangan dulu. Oke, jangan dulu katanya.
Mas Wisnu mau nanya. Ya, jadi kan tadi kata Sebastian kita butuh sketchpad sebelum dan sesudah PyGuessWait-nya ya berarti ya?
Jadi sebelum dan sesudah. Tadi kan kalau di versi sebelumnya kan cuma ada satu sketchpad nih untuk kalimatnya.
Ya.
Nah, sekarang eksperimennya adalah kalimat yang kita kasih lihat ini akan berubah begitu partisipan mulai menggerakkan matanya. Sehingga akan ada setidaknya dua sketchpad. Sketchpad yang pertama sebelum kalimatnya berubah, dan sketchpad yang kedua setelah kalimatnya berubah. Di antara kedua sketchpad ini, kita kasih si item weight itu.
Oke. Terus jadi harusnya, ini kan ada pilihan nih.
Sorry, ini kalau agak masuk-masuk suara.
Ya, nggak apa-apa Mas, kedengeran kok. Di PyGuessWait-nya itu kan ada pilihan-pilihan tuh ya. Ada yang sakade, start, wait, terus, nah itu pilihnya yang mana ya?
Nah, karena ini kita tadi akan membuat dia kalimatnya akan berubah. Sakat itu adalah gerakan pupil mata. Jadi sebenarnya nanti kalau kamu ke lab bisa kutunjukin juga dengan eye tracker yang kita punya. Kalau misalnya kita baca kalimat, kesannya tuh kan gerakan mata kita kan begini. Atau ketika kita misalnya ngikutin ngelihat misalnya sebaris orang satu-satu gitu. Kita ilusinya kan seakan-akan kayak gitu. Padahal yang terjadi adalah gerakan matanya itu. Nah, satu kali loncatan ini kita sebut sebagai sakat. Nah, kalau kita baca satu kalimat dengan asumsi bahwa orang itu akan baca dari satu kata ke kata yang lain, berarti kalau kalimatnya itu terdiri dari 5 kata, akan ada 5 kali sakat. Di kelompok yang hard, mereka lagi bikin supaya ketika ini sakat yang keempat, baru kalimatnya berubah. Nah, di kelompok yang isi ini, dia akan berubah seketika itu ketika kita mulai menggerakkan mata di sakat yang pertama. Sehingga,
berarti sakat start tuh ya?
Sakat start, betul.
Oke, tapi berarti nggak bisa baca apa-apa dong si partisipannya gitu nanti?
Karena sebenarnya seperti tadi kata Sebastian, ketika kita disuguhkan satu kalimat, objek atau apapun itu, sebenarnya kita udah dapat istilahnya itu gist. Jadi gambaran utama, ini kira-kira tuh apaan sih? Overview lah.
Oh iya.
Nah ini kita bicara soal VSTM, Visual Short Term Memory. Jadi yang baru masuk ke dalam retina. Jadi kalau di biopsikologi itu areanya itu area V1, baru yang awal-awal banget.
Ya, oke.
Kalau ini bayangin kalau kamu lihat kembang api gerak-gerak gitu, sebenarnya kan ketika kita gerak-gerak itu kan nggak ada garis-garis itu. Garis-garis yang kita lihat itu sebenarnya adalah efek samping dari si visual short term memory ini. Cahayanya kan udah bergerak ke tempat lain.
Ya, paham.
Tapi kita masih ada ilusi bahwa oh ya ada bekas-bekasnya. Si bekas-bekasnya inilah yang tadi ketika kita kasih lihat satu kalimat, dia itu sebenarnya udah masuk. Jadi kita nggak perlu nunggu sampai mata kita bergerak baru bisa baca.
Oke. Yes.
Ngapain saya baca? Tadi mau tunjukin sakat tapi mata saya terlalu.
Iya. Nggak kelihatan Mas.
Anyway, begitulah kira-kira gambaran.
Oke, tadi saya udah nyoba nih ya. Kalau misalnya pakai sakat yang start, waktu apa namanya mouse-nya bergerak ini kan berarti itu ikutin ceritanya mata kita gitu kan. Pas saya mulai dia langsung hilang. Nah, bukan ganti kalimat tapi hilang kalimatnya.
Karena kamu set. Jadi kan, tapi ini jadi bocoran. Yang lain kayaknya lagi mau coba dulu deh. Jadi itu tergantung dengan duration sketchpad-nya.
Durasi sketchpad yang kedua.
Yang pertama, baik yang pertama maupun yang kedua. Jadi sketchpad ini dia akan nunggu sampai ada item berikutnya. Dan item berikutnya ini punya durasi sendiri kan. Kalau misalnya kita kayak misalnya kemarin kasih tunjuk sesuatu terus ada keyboard response. Poinnya justru pakai masker itu bersihnya di dalam masker.
Oh, buka masker bersih. Oke.
Anyway, tadi sampai mana?
Iya. Tadi kalimatnya hilang. Harus
Ya,
harus
jadi
setting
kalau kita kasih
durasi.
lihat objek
Ya.
dan dia akan stay misalnya 2 detik, dia akan nunggu sampai ada item berikutnya. Nah, item berikutnya ini punya durasi juga nggak? Kalau item berikutnya ini punya durasi, dia akan nunggu sampai durasi item berikutnya ini selesai. Makanya kemarin kasih lihat sketchpad 2.500. Oke, kita mau collect responnya 2.500 juga. Nggak bisa, jadinya totalnya jadi 5.000. Kalau kita mau kasih lihat sesuatu dan collect response, ya berarti ini di set ke 0, ini 2.500, gitu kan? Nah, hari ini logikanya sama. Tapi kita nggak collect keyboard response, tapi collect waktu sampai matanya bergerak. Sehingga si yang pertama ini harus di set berapa nih? Sampai matanya bergerak. Dan yang kedua harus di set berapa nih? Sampai ada apa lagi di belakang. Gitu. Kira-kira.
Oke, Mas Wisnu. Saya coba dulu. Thank you, Mas.
Oke, selamat mencoba.
Ya.
Hey, so we're back from the hard breakout room. How are things going here? So pending an answer, my suggestion would be that I briefly walk you through the logic of the easy and the hard solution. For assuming that not everyone is already done. And for the hard solution, don't worry if you fully understand it, but it will at least hopefully give you a sort of a conceptual understanding of how you can do pretty complex things. Even though actually being able to do it yourself will require a bit of knowledge of various things. Shall I, Wisnu, shall I share my screen and walk us through the easy and the hard solution?
Yeah. I think most of the people who are trying the easy solution have managed to do that. So I'm super happy with that.
Okay, good. Well, I will be very brief then. Good. Okay, so you're looking at my screen now, and the only thing that I did basically in the block loop is I made 2 sentences rather than 1, and the 2 sentences differ based on their last word. So bunnies are soft and furry turns into bunnies are soft and scaly, and lobsters are soft and furry turns into lobsters are soft and scaly. And then the goal was to present sentence 1 until participants make a psychetic eye movement and then change it into sentence 2 without any Python code. And the implementation, and I'm sure all of you arrived at the same, is that in sentence 1, we just present sentence 1. The duration is 0. So we immediately move on to the PyGaze wait item. It waits for the start of a saccade. As soon as the saccade starts, it moves on to the next sentence, sentence 2. And then it moves on to collecting a keyboard response. And that's it, basically. And then we can run that and we can see that it behaves as we want it to. So we start with the drift correction. I move my eyes there. Up, lobsters are soft and furry. And as soon as I make a saccade, tack, it turns into scaly. Up, bunnies are soft and furry. Bunnies are soft and scaly. Okay, so far so good. And now let's take a look at the hard solution. So I opened the Venus hard. I will share them in the chat, both files, by the way. Now, almost everything is the same, except that in the block loop, I added a column that is called boundary. And it is -220 or -205. And why? Well, because those 2 sentences are a little bit different. So let's actually take a look at how I arrived at those values. If I go here and I just draw here, okay, bunnies are soft and furry, and on the next line, lobsters are soft and furry. Oh, and I don't center it like this. And then I sort of investigate, okay, where is the boundary? And the boundary should be just before the end, right? So let me zoom in a little bit. Then for the bunnies, if I look here at the top right, you see it's around -220, right? The boundary. And for the lobster, it's a little bit later. It's around -205, say. So that's where I arrived at these boundary coordinates. So the boundary reflects the horizontal, the x coordinate, just before the word end. And what we want to do is change the experiment such that the sentence is changed at the moment that participants cross this boundary. So from soft to end, boom. I hope that logic is clear. Now, but of course we cannot magically do that. We need to do a little bit of programming here. And that's why I call this the hard solution, because it requires a bit of Python code. But I hope that you will see it's actually not so bad. So here I have a Python script. And this is all there is to it. What I first do is I define the coordinate that needs to be crossed. And I call it x boundary. X boundary is the boundary variable that we defined in the block loop. And in Python script, instead of using these square brackets, you say var dot, and then the name of the variable. That's how you refer to experimental variables, because square brackets mean something different in Python. They mean that you turn something into a list, essentially. And then we have this weird thing here, and this is to accommodate for the fact that Pygaze actually treats 0.0 as the top left of the display, and OpenSesame treats 0.0 as the center of the display. So what we're doing here is we're changing the boundary coordinate that is relative to the center of the display, and we're adding half the width of the display to it, so that we actually convert it to a coordinate relative to the left of the display, as Pygaze expects. I hope that makes sense. Then we start an infinite loop, while true. If you use Pygaze, there is always an eye tracker object available to you in Python code. That magically happens, it's just there. And the eye tracker object has a sample function. And the sample function returns the coordinates. It returns two coordinates, an X and a Y coordinate, and we assign that to here. But we're only really interested in the X coordinate. And we check if the X coordinate exceeds this horizontal boundary that we defined. It means that the eyes went over the boundary. Then we break this infinite loop and we are done. And we present the next sentence. So the break statement means exit the loop, basically. I hope that makes some kind of sense. I appreciate if you don't have experience with Python and programming that this is complex to follow, because it is a loop and it requires some things. But I hope you feel at least that this is not rocket science and very short, actually, how you can do this. Now let's take a look then, if I run it. Up, drift correction. Now I'm going to read bunnies are soft and scaly. Bam. Enter or space. Lobsters are soft and scaly. Wow. And now we have a true boundary paradigm. And the only thing that you would need to do is basically for all your stimuli, determine the correct boundary, right? That is not automatically detected. You're actually manually putting it in here. And there are also ways to do that automatically, but that becomes very complex very quickly. So I didn't want to touch upon that here. All right. Yeah, so let me share this in the chat, actually.
Maybe to add a bit on that. So there is this variable inspector. So if you click view and variable inspector, you can inspect all the variables that created by OpenSesame. And you can also, shall we talk about the debug window?
Yeah.
There is this debug window that you can also write all the things that Sebastian read right there. If you try write it again there, you can inspect the values that is already assigned to that, and then it will return the current value, right?
You mean that you mean that
say
you
like
can
count trial sequence, then it will return the value.
Yes, at the end, that's true. Yeah, if you say var.width, for example, yeah,
then you get the values, so you don't have to.
So that's true. So at the end of the experiment status says finished, and then you can here in the variable inspector sort of see what all those variables are. You can also see them evolving live actually during the experiment. Maybe that's fun, an interesting exercise to do. So if I click on up here, you will see that the experiment is running. And if let's take a look at sentence, for example, my sounds up, you will see that it is now showing the lobsters and stuff. And then up, lobsters are soft and up, scaly. Now we're done. We go to the next sentence, and you see that it actually changes in the variable inspector. Bunnies are soft and scaly. And then when the experiment is done, indeed, you will see that here in the variable inspector. And you can also programmatically sort of access the status of the program by saying, for example, here, var.sentence1, var.sentence2, to var.boundary, etc. So there are various ways to sort of access the state of your experiment after you're done. That's pretty advanced stuff, especially in a console. But for the variable inspector, it's quite easy. And also what is nice about it is that you can sort of monitor, say that you have made some kind of complex experiment, and then you want to see, you can use the variable inspector to kind of see whether the values that you see there actually match what is happening on the display during the experiment. Or for example, you can say, I'm going to monitor the correct variable, and then you can see whether the correct variable indeed is 1 when participants give a correct response and 0 when it is not, when they don't, just so that you kind of check the logic of your experiment, so to say. All right, yeah, this is it. I think I also want to leave some room for everyone to work on their own experiment. So, but before we do that, let's say that do people have questions? Does anyone want to ask something about this or say something? No, is this all more or less clear? Shall we then say, Wisnu, that we do the same as we did the previous days? You join the people who want to continue working on this in the breakout room. I'm not sure there are many people actually now that want to do this, because I think most of us are actually done with it. And the people who stay here in the main room, I will sort of ask you how you are doing with the experiment and make our rounds, so to say. And then before we close the workshop, and I think this might also be a nice moment to take a 10-minute coffee break or something like that. Huh? Yeah. I think. Yeah.
So yeah. we start again at 4:30 this our time, and your time is like 10:30.
Exactly. Let's do that. Okay. All right. Then in 12 minutes we'll reconvene. All right. See all of you in a bit.
I assume that it will stay in the main room, and I think people here want to discuss more about the HTML forms, and I will go to the breakout room for those of you who would like to continue working on the sentence, the gaze contingent experiment.
All right, yeah, so follow Wisnu to the breakout room to continue working on the gaze contingency, and otherwise I will stay here and make a round to ask how everyone is doing with their own project. And Wisnu, can you actually, before you leave, post the link again to the spreadsheet?
It's the same file as yesterday, so nothing has changed yet. But
I cleared my downloads folder, so I don't have it anymore.
Yeah. Should have done the same, but I'm lazy. Yeah, so I still have it in my download folder as well. So that's it. And put it in the chat. Right.
Ah, there it is. Okay. All right. Let's download. Okay. Well, there we go then. I will make my rounds, so to say. Let's see who is. So from the top down, let's see who is here. This may be a little bit repetitive, huh? Because I know that we already did this yesterday, and you haven't made, I'm sure, incredible progress. But I'm nevertheless going to make the round. So, all right, let's start with Pingang. So the stress management. Yeah. So by now I'm starting to remember what all the projects are about. So the idea is using the stress inducer to. How are you with that?
Well, not very much development yet. However, now I know that I would like to learn more about the HTML function, because in one of the trial I would like because the dependent variable is accuracy of perceiving emotion. So I need to display an image and then ask the participant to answer in what are the emotion that is displayed. So I think for today I want to practice creating that part of the procedure.
Okay, yeah. So you want to do this online, and then you want to
online.
the main reason to actually then use HTML as opposed to just the built-in things is, I suppose, that you want to present the emotion and at the same time below it have some kind of input that that asks them. And how would you like them to answer? What is the way they should?
I think it's a multiple choice. So, for example, the image is displaying anger, and then maybe it's radio. No, I think it's radio button.
Yeah.
So the participant can choose one right answer. Probably, for example, the displayed image is anger, and then I will have anger, sadness, and surprise, for example, as the options, and they are expected to answer anger.
Okay, yeah. So, all right. So then indeed, then it is a matter of creating 3 radio buttons and an OK button to submit the result. And then you attach a variable basically to the radio button so that you actually register what they clicked on. And of course, the image should also be embedded.
Okay, let me think about it. Not really sure how to do it, but I think.
And one thing already to take into account that you might run into is if you use images this way, by including them through HTML, you can actually not refer to the 2 images in the file pool. So you have to actually refer to images that are somewhere online and put the actual thing in. Okay. Yeah.
Yeah, I get that. Yeah, I will provide the image online. Probably just upload it in my blog or something, right? Just to make it available. About the image, I just need to make it online. For example, I have the image, and then I will upload it in my blog, and then I will copy the link from there to input in the OpenSesame.
Something like that sounds right. Yeah. Okay. So, and by the way, no one is forced. If you're just saying, okay, I don't necessarily want to work on my own project, or I honestly don't know, then you just tell me, right? I don't want to put anyone on the spot. Other than that, I see Daddy is not here. Farah is also not here. Raymond, not. Woody. Lulu. Yeah, Lulu. All right, so we were talking about this yesterday a little bit. Can you refresh my mind where we were? Are you there actually, Lulu? No, she may not.
Here.
Oh, all right. I need a brief memory cue actually to remember what we talked about yesterday.
What we talked. Wait. Okay. In my research, I want to show a promotion video by celebrity endorsers and by typical person maybe, and see by intentions of the participant.
Oh yeah. Okay. Yeah, of course. So in that context, we looked at how you can embed a video in an HTML form and get a question. So it's actually very similar to Pinkon.
Yes.
Yeah. Okay. I remember again.
Exactly.
Do you have specific questions about that actually?
Not yet, because there are not many changes in development from the experiment concept right now. I'm still try and break down the concept right now.
Okay. Yeah. Yeah. That sounds good actually. So one thing that I'm now actually thinking, and that you might run into, and that Pinkon also might run into, is how to, you have a form, of course, an HTML form. And that HTML form should display a stimulus. And that stimulus will be defined in the block loop, right? Or somewhere, and at least it will be defined through a variable.
Yes.
And now I'm thinking, how do you actually embed that variable in the inline HTML? And I'm actually not entirely sure myself. So why don't we say that I continue this round first, And then afterwards, I will take a moment actually to figure that out and give you some concrete suggestions on how you can do it. And then Esther, no idea yet, but I'm interested in problematic internet use, well-being, and nostalgia. Did we talk about that yesterday? So yeah, there's sort of some things are a little bit fuzzy in my mind again, but if I have a short memory cue, I will remember. If Esther is back, we'll pick this up.
Emergency discussion. So
okay.
It's actually behind me, if you can see. So yeah, we'll pick that up later. We'll maybe continue to the next person.
And William, yes, I remember. Actually, we ended our conversation with me suggesting that you actually narrow the question down from something that relates to a topic and a technique to an actual research question, right? And then I gave some pretty random suggestions, like doing a Posner queuing paradigm or a continuous performance task, or something that assesses that you can implement and that assesses something related to attention. How are you with that? Is there something, do you have a more concrete idea? Is there something that I can help with?
Yeah, so actually, thank you for that suggestion. So I followed the suggestions and take one step back to rethink about the research question. So now I'm particularly interested in this is one of your suggestions also. I mean, not your suggestions, but just now you say about nystagmus.
Okay. Sorry, I had you broke up the connection. Can you say it again?
Sorry. Yeah. So just now you said about nystagmus, but the eye. I think is it an eye problem? Yeah, eye problem. So I mean, from what I've read. ADHD sometimes is like associated with eye problems, but it's still not. But it is still not determined whether ADHD associated with eye problems. So maybe I'll try to narrow down my topic to see if there's like the relations between ADHD with eye problems.
Okay.
And with the topic, I finally realizing like the methods of that I'll be using. So maybe I'll use, not maybe, but I will use like just now like Eye Tracker. So I mean, like the basic concept is like just now you explained about that, and maybe using like reading sentences and then just tracking their eye movement. Is there any like dissociative eye movement or something, and that will determine if that person has an eye problem and something like that.
So I would say using eye movements to sort of study whether people have ADHD symptoms is done a lot, of course, and it's a good idea. But it requires also a prediction, right? If you formulate a prediction like I have them perform a task and I'm going to see if there are differences, that I would say is not really a good prediction because it's too open. What do the differences mean, right? Do you mean that they are, especially with the sentence, you will have very complex eye movements? Do you mean that they have more regressive saccades, that they skip sentences, that their eye movements are faster? Do you mean that they spend more time on individual words? There are many, many things that you can study in that sentence, and that makes it almost undoable. That means that if you collect data, you will have lots of data and no idea what to do with it. So I would say narrow it down to one dependent variable that you might be interested in, and then say I predict that people with ADHD have more of this compared to people without ADHD. This can be in sentence reading. I'm sure there will be differences in maybe they skip more words or something like that. You can also think of even a simpler paradigm. For example, but this has already been done a lot, but it might still be interesting to look at. Say that you take something really easy, like you have participants, you give them a task to look at there are 3 stimuli. Let me actually draw it, basically. It's really simple, but I will draw it anyway. You give them a sort of a visual search task, I'm not saying you should do this, right? But just as an example of something that is very, very specific, and it would make sense in the context of ADHD, I think. Move this. You have a fixation dot in the center, and you ask participants to look at the unique shape. And then there's always like a square, that's the unique shape. And up. And then there are 3 circles, right? So the square is clearly the unique shape, and their task is to look at it. But you make all of them kind of gray-ish. They're not very visible. And this one is actually bright red. Now, then as soon as you do that, right, so you present this, then participants will have a very strong inclination to actually make an eye movement to the unique object, right? Because it is very salient and it captures your attention and you're inclined to make an eye movement to it. But your task is, of course, to make an eye movement to the gray square. Now, everyone makes mistakes there. So on a proportion of trials, people make an eye movement to the target, and on a proportion of trials to the distractor. But for people with ADHD, almost certainly that proportion of trials where they make an eye movement to the distractor will be higher than when they make an eye movement towards the target. And what is nice about this paradigm, as just one example of many things that you could do with an eye tracker and measuring attention, is that it gives you a very clear measure, right? Namely, the proportion of trials in which people make an eye movement towards the distractor. And you can correlate to what extent that measure correlates with, you can test to what extent that measure correlates with the ADHD traits, basically, that the participants have. So, and this is not so much an example of this is what you should do, but just a general approach, I guess, that I would take. Like, think of a pretty simple thing that gives you one very clear measure, and then think, well, how am I going to correlate that measure with presumably some kind of results from an ADHD questionnaire, right? Because that's what you would need then.
Okay.
Is that helpful?
Thank you. Yes. But actually, I have some more few questions if I'm allowed to ask.
Yeah, of course.
I think it's just basic OpenSesame questions. So, so the first one is, so I'm using Mac OS, and then I found trouble in, so like my experiment, like every experiment that I built with OpenSesame will, like as soon as I started, when I'm using earphones, there'll be an error, and the error message will be port audio error or something.
Okay.
Is that, I mean, is that something that I will face? And so just now I tried to change the PsychoPy to legacy, and that works. I mean it works. So I'm just to clarify that.
This is, I don't know. Basically, this seems to be a very system-specific error related to an interaction between PsychoPy and something to do with your earplugs. So I would, my suggestion indeed would be to try another backend then, and not otherwise worry too much about it. But these things are always difficult for me to say because there are millions of different systems out there, and then sometimes you get these kinds of errors. So
okay.
I don't know.
And then the last questions. I mean, it's not entirely like important question, but I mean it's just bothering me every time I use my OpenSesame. Can I share my screen?
Mm-hmm. Yeah, of course.
Okay, so just wait. So every time I open my OpenSesame, so it should be like this. Oops. Sorry for that. Okay, so every time I open, there will be like this thing, display scaling status. That, I mean, is there any way that I can change that?
No, it is, well, yes, you can disable the display scaling on your computer, and then the thing will go away. So what it refers to, it is a warning, basically. What you have enabled on your computer, and a lot of people have that enabled nowadays, is that there is that the operating system automatically changes the size of stuff to compensate for the fact that you probably have an extremely high resolution monitor. So that means that things otherwise become tiny and it makes it bigger. That's what the display scaling refers to. If you then run an experiment, it depends very much on the operating system and the backend that you use. But you can get weird artifacts, such as that the mouse position is misaligned because things are kind of changed in their size, or that actually the full screen thing doesn't appear full screen, but it is sort of in the top, dangling in the top left of the monitor. Ugly things in any case. It doesn't really matter very much for testing the experiment, but in any case, on a laboratory computer, you definitely want to disable that, and that's why you get that warning.
Okay, so and then the last one. Sorry.
No, that's why I'm here. Huh? I'm here to ask questions.
For example, every time so this is just for example. So every time for example, this is full screen, right? So every time I open like another item, and this comes to my timeline, it will
it will run out of. So this is a bug essentially in the library used for the user interface, a library called Qt. What you can do is if you click in the toolbar, you see this button that is sort of like this, like two lines going into one arrow. That is one tab mode.
Mm-hmm.
If you enable that, the tabs will disappear, and you will only have, and then that won't happen anymore.
Okay. Okay then. Thank you so much for that.
Yeah, but there are then in general you will see actually on macOS some things just don't look as nice as they look on other operating systems, basically.
Okay, no worries. Thank you, Sebastian.
Yeah, welcome. All right. Reinhard, I remember yesterday we also talked about we were talking about this idea of emotion recognition, how well you are able to recognize emotions. And we had to talk about to what extent you wanted to manipulate actually emotion recognition or inducing emotions, if you are there actually, Reinhard. He may not be. All right. So, all right. Finally. All right, then we've had everyone here in the session, actually, I think. If Reinhard comes back, we'll pick this up. And then Lulu and Pinkan, let me actually now try to, I'll stay here. I will try to actually give you an answer on how to embed variables in the form, basically in HTML form.
Okay, and I found some websites that provide pictures. I think it's you can really just take the picture.
Yeah, you can literally copy paste the URL then probably.
The website provides picture with certain balance and a certain arousal.
Oh, okay. All right. Nice.
But we need to download the picture first. We can just copy. Maybe we can just copy the link. I don't know. what I have in mind is we upload the picture that I upload picture that I want to use to a certain website, and then I take the link from there. I don't know if it makes sense, or is it the right way to do it? I think you muted yourself. Is it on purpose or?
Sorry, you're right. No, so you're on the right track. Just try to find URLs to get some way to get URLs of your images. Okay. And then what I'm trying to find out now is how you can actually embed variables in your form, basically. actually, this is a little bit more tricky than I thought, Pink and Lulu. So let me get back to you that at a later point. Basically, it is the HTML form has a lot of very nice attributes, but is not very good at listening to variables from elsewhere in the experiment. So I have to think about this a little bit, actually.
Okay, so we can display it, but cannot connect it to the experiment.
Yes, for now, yes, that's basically what it boils down to. And that is, there has to be a solution for it. I'm sure there is, but I have to think about it for a little while.
Okay.
Sometimes these kinds of things that seem so easy are for reasons that are essentially poor design, just not as easy as they should be.
Yeah. Okay, I'll wait for the next session. Thank you.
All right. Yeah. So then it's 12. So why don't we invite the people from I will join the other breakout room, and then ask them to come. No, you know what? Actually, I will ask you, do you have some final things that you would like to ask or say? Then this will be the moment. If not, I will go and say hi to the other people in the other breakout room.
I think no, I just need to sync all in and practice. Thank you.
All right. Well, then thanks. I thought I enjoyed the workshop today. Thanks for participating. And then we'll see each other next week, actually, next Wednesday, right? Yeah, so in 6 days. Good luck, have fun with it, and then talk to all you guys soon.
Thank you. Bye.
And I'll join the breakout room.
Yes.
Thank you, Sebastian.